Hello students, here we have problem number 29 from chapter 6. We have to calculate the force required to pull a copper ball of radius 2 cm upwards through a fluid at constant speed 9 cm per second. Take the drag force to be proportional to the speed with proportionality constant. Ignore the buoyant force. Now, first of all, before moving on, let me explain what does mean buoyant force. Now, buoyant force is basically the upward force that fluid exert on any object that is placed in them. So that means if you have an object, let's consider three scenarios, okay? First of all, suppose we have a ball. Now it has the weight. Now buoyant force will be pointing upwards, basically. Now, if buoyant force is smaller than the weight, then the object will start sinking below. Okay. Suppose if the buoyant force is greater than the weight, then the liquid will push the ball upwards. Okay. If buoyant force is equal to the weight, then the object will just float on the surface of the water. Okay. Now generally we have a formula for the buoyant force, which is the density of the liquid, then the volume, where how much the object is immersed on the water, and then multiplied to the gravitational constant G. Okay. Now let's go back to our problem. In our problem, what's happening is that we have an object, we have a copper ball. So the copper ball is pulled upwards. Okay, let's say F applied. And it's moving with a constant speed upwards. V constant, which is equal to 9 centimeter per second. Okay. The radius of the ball is also given. This is our radius. So the radius of the ball is given, which is equal to 2 centimeter. Okay. Take the drag force to be proportional to the speed with proportionality constant 0.95 kilogram per second. So that means we have proportionality constant, which is a B, which is equal to 0.95 kilogram per second. Okay, so let's look at this copper ball and try to understand how many forces are there. Now, first of all, we have, since object is moving upwards, we have resistive force, which will be pointing downwards. Okay, it basically resists to the motion. Then what we have? Then we have here the weight of the copper ball, which is mg, right? Or in other words, we have a gravitational force which will try to pull it downwards. So let's write down the equation that the sum of the forces is equal to ma, right? Now what are the sum of the forces here? First of all, it's applied force, which is pointing upwards, minus resistive force minus Fg. Since object is moving upwards with a constant speed, that means acceleration is 0, so therefore is equal to 0. Then we can say that our F is equal to R resistive force plus Fg. Now, what is the formula of the resistive force? The resistive force is equal proportional constant B speed plus mg, right? Do we have m? We don't have m, but we have the radius, right? If we have radius, then we can get the mass. So how can we find the mass then? The mass is equal the density of the copper ball multiplied to the volume, which means density of the copper ball. The volume of the sphere is 4/3 pi r cube. So if we put everything on the formula, then we should get that F is equal BV plus M is equal rho density of the copper 4 divided by 3 pi R cube multiplied to the G. Okay, this is the formula. Then you have to plug the numbers to get the answer.